When you think of great physicists, you probably think of people like Isaac Newton, Albert Einstein, or maybe even Michael Faraday. However, one that doesn't come to many people's minds is James Clerk Maxwell. Maxwell's work in electromagnetism has really shaped the world to how we know it today. He took different scientists' ideas and unified them to create 4 equations. With his 4 equations, he's able to describe electric and magnetic fields and how the two interact with each other to form electromagnetic waves. His first 2 equations explain electric and magnetic fields by measuring divergence. Divergence is when you take a portion of a vector field, an area without a unit of measure at each point, and measure the flow of arrows in and out of the portion, like water in this tub. You see the water coming out of this hose and going down this hole. If we were to map the direction and strength of the flow of water using arrows, we have a vector field. By measuring the flow of arrows right here, we would see that the arrows flow in and out of the center of the tub equally, meaning a divergence of 0. Maxwell's equations show that a magnetic field's divergence will always be 0, like the center of the tub, because no matter where you measure divergence, the flow will be even. You can see this in the picture where the magnet force flows around and through the magnet. No matter where you measure the divergence, it will always equal 0. However, in our water example, that isn't the case. The area around the hose has a positive divergence because there's more flow coming out than in, and the hole, which has more water coming in than out, has a negative divergence. Since the tub doesn't have a divergence of 0, this experiment is a more accurate representation of an electric field than magnetic. In an electric field, the electricity moves out from a positive charge to a negative charge, just like the tub. Maxwell's 3rd equation, to put it simply, means that a changing electric field causes a changing magnetic field, or vice versa. In the 4th equation, Maxwell describes a magnetic field around a current-bearing wire. Ampere's law, a law created by another physicist, describes this magnetic field. However, the issue with Ampere's law was that it didn't allow for a changing field. And so what Maxwell did to solve for this was to take into account the changing fields in order to make his 4th equation, which describes the magnetic field around the current-bearing wire, even if the fields are changing. Using his 4 equations, Maxwell made another discovery. This discovery was the way electric and magnetic fields interact with each other. This interaction creates electromagnetic waves. These waves are what make cell phones and radios work. And with his discoveries, people were able to create these inventions. With them, we can communicate all throughout the world using text, audio, and video, like the one you just finished. Thank you.